So we are now in part 4 here. So the part 4 here is about the proof of derivative identity of Legendre polynomials. So we start with the given function here, f of x equal to x squared minus 1 raised to the n here. So this is the base function in Rodrigues formula for Legendre polynomials. So y of x equal to p of x, so this is equal to 1 over 2 to the n factorial and derivative of f of x. So here our uh, x squared minus 1 here is equal to uh, x squared minus 1 is equal to f of n is equal to n derivative of uh, f of x. So where the n derivative of x here denotes the n derivative of f of x here. So f of x equal to x squared minus 1 raised to the n is a polynomial of degree 2n, and its derivative are central to the proof. So we have to apply the Leibniz rule to the differentiate x squared minus 1 f prime of x equal to 2nx f fx. So we have to apply this in times, this Leibniz rule. To verify the initial equation here, to differentiate the f of x equal to x squared minus 1 raised to the n. So we have f prime of x equal to 2nx x squared minus 1 raised to the n minus 1. Then multiply both sides here by x squared minus 1. So x squared minus 1 times f prime of x. So this is equal to 2nx x squared minus 1. So then we have this becomes 2nx because f of x here is equal to x squared minus 1 raised to the n. So this identity is the starting point for the recurrence. So differentiation, differentiate both sides in times using Leibniz rule here. So Leibniz rule states, so this is the equation for the Leibniz rule. So the left-hand side here, so this is x squared minus 1 equal to f prime of x here. So this one. So our e of x here is equal to x squared minus 1. And v of x here is equal to uh, f prime of x. So derivative of u of x. So the given u of x is equal to x squared minus 1. The first derivative here is 2x, and the second derivative here is equal to derivative of 2x equal to 2. So the case derivative of u is equal to 0 for k greater than or equal to 3. Thus, the n derivative of this expression is equal to these expressions. For example, by using Leibniz rule here, so n combination of n taken 0 at a time is equal to 1 here, so x squared minus 1. Then we have to increase the first derivative here. So the first derivative is uh, f1, so plus n here. So this is times n plus 1 derivative of f of x. Then we have here in 1 here, the combination of n taken 1 at a time is equal to n here. Then multiplied by the derivative of x squared minus 1, that is 2x. Then uh, we have to decrease the derivative here. So the derivative is n plus 1. So minus 1 here is equal to n. Then the next one here is the combination of n taken 2 at a time is equal to n times n minus 1. So this is equal to um, so this n and k is equal to 2 here. So this is a combination of n taken 2 at a time is n minus 1, and then multiplied by decreasing the derivative of uh, n derivative here. So n minus 1. So n minus 1 derivative of x here. So supposed to be this is equal to we still have to multiply here the derivative of 2x is equal to 2. So 2 times n minus 1. Now over the n factorial here. So 2 over 2. 2 over 2 factorial is cancelled. So what we have is the remaining expression n times n minus 1 times the n minus 1 derivative of f of x. Okay. Now the right hand side here. So this is 2nx, the right side, and if v of x equal to fx here. So here, so the 2nx f of x. So derivative of u of x here is no derivative, that is 2nx. First derivative is equal to 2n. Then k derivative is equal to 0 for k greater than or equal to 2. So the n derivative of 2nx f of x equal to, so we have the 2nx here times the uh, n derivative of x times n here. So we have the combination of n taken one at a time is equal to n. So n times 2n is equal to 2n squared here. And we decrease the derivative here. So f of n, n derivative here. So this becomes n minus 1 derivative of f of x. So equate the left hand side and the right hand side here. So this is the left hand side. We have here this is the right hand side here. We have the right hand side here. This is the left hand side. Then cancel 2nx times the n derivative of f of x here. So we have the cancellation of 2nx n derivative of fx. So we have the remaining expression here. Then solve for x minus 1. So x minus 1 here times the n plus 1 derivative of x. So we have the remaining expression here, 2n squared. Um, so we have a 2n times n minus 1 derivative of x, then minus this one. So we have a common factor here. This one, n minus 1 derivative of x. Then we transpose this positive n times n minus 1. So this becomes negative. Multiply with a common factor here, the n minus 1 derivative f of x. By simplification here, so we have the remaining term here, n times n plus 1 times n minus 1 derivative of x. So this gives the recurrence relations. So we have x squared minus 1 times n plus 1 derivative of x. So by simplifying, we have n times n plus 1 of the n minus 1 derivative of x here. So use the recurrence to derive the target identity. We aim to show that this derivative of 1 minus x squared y prime is equal to n plus negative n plus n times n plus 1 y of n. So the expression yn of x in terms of f of x, in terms of f of x, the n derivative of f of x here. So from Rodrigues formula, y of x here is equal to 1 over 2 to the n factorial times the n derivative of f of x. Then we have the derivative of this y prime of x equal to 1 over 2 to the n factorial. So this is constant, so no worry about its derivative here. So we have the n plus 1, so we increase the derivative here. So n plus 1, so n plus 1 derivative of f of x. So we are going to compute the derivative of 1 minus x squared y prime of x here. So we have this. So we have the derivative of this 1 minus x squared times y prime of x. So this is equal to 2n. The derivative of this 2 to the n derivative of this. So negative 2x here times n plus 1 derivative of x. Then multiplied by 1 minus x squared times the next derivative of f of n plus 1. So f of n plus and this becomes f of n plus 2 here. So f of relate the n plus 2 derivative of x using the recurrence formula. So differentiate both sides of equation 1 here. So this is our equation 1. So differentiate both sides of equation 1. So we have this x squared minus 1 times uh, y of n plus 1 derivative of x. So this is equal to, so this is our equation 1 here. Okay, so this is our equation 1. So the derivative of both sides here is given by this. So given by this. So the left side here is 2x here times n plus 1 derivative plus x squared minus 1. So derivative of this, x squared minus 1 times the next derivative here is n plus 2 derivative of x. And the right side here is n times n plus 1 is a constant. So the next derivative of n minus 1 is equal to n. So n minus 1 plus 1 equals to n. So we have the left side is equal to the right side here. So the left side here is equal to x minus 1. But we transpose this to x to the right side. So this becomes negative 2x of the n plus 1 derivative of x. Then we have also this, the right side. So the remaining term in the right side here. This is the original term in the right side. So n times n plus 1 times the n derivative of x. Then we substitute the equation 3 into equation 2 here. So this is our equation 2. So this is our equation 3. Substitute this equation 3 into equation 2. So we have following this. So derivative of this with respect to x is 1 minus x squared y prime. Then we have this 1 over 2 to the n factorial. So negative 2x here times the n plus 1 derivative of x, then minus n here. So 1 minus x squared here is 1 minus x squared times. So where does this come from? So from equation 3 here. So this is negative 2x. So we substitute here, this one. So this becomes 1 minus x squared here. So this one x squared minus 1. So we factor out the negative sign here. So then we transpose it to the right side. So this becomes negative n times n plus 1 and derivative of x. So this becomes positive. So negative times negative here. We transpose the negative sign here. So this becomes 1 minus x squared. So this becomes negative times negative equal to positive. So we have the negative times negative equal to positive here. So we are going to simplify this now. So this one, this negative n times n plus 1 n derivative of x over 2 to the n factorial. So we have this expression. So this expression is equal to y n of x. So by substitution now, so the derivative of 1 minus x squared y prime over x with respect to x is equal to negative n times n plus 1 times y n of x here. By substitution here.